Assigning hybridization for the following structures. You should put in the back of your mind that the formula most universal and acceptable one is this sp n minus 1 or explain, where n is the number of atoms attached to the carbon that you are assigning the hybridization. Let's look at this case as a study. Let's look at assigning hybridization for this carbon. You discover that we have 1, 2, 3 hydrogen attached to the carbon, and we also have this second carbon here attached to it. So we count the number of atoms attached to the carbon. So we're going to see we have 1, 2, 3, including the carbon that is attached to it. We're going to have 1, 2, 3, 4. So n becomes 4. So we're going to say sp 4 minus 1 is going to give us sp3. So this carbon becomes sp3. Now, before we continue, let me give you a super trick. Now, when you see a single bond, it's an sp3. When you see a double bond, it's an sp2. When you see a triple bond, it's an sp hybridization. But it doesn't work in all cases. But this is the universal one that works in all cases. So when you come to this carbon, it becomes sp3. This carbon becomes sp3. This carbon becomes sp3. Now we move down to this carbon becomes sp2. This one, this is a double bond, becomes sp2. This one, now we check out for this if it's going to be a double bond or a single bond. Let's give it a try using the formula method. Now look at this carbon. It has been attached to one atom here. This particular carbon is what we're looking at, and it's also attached to another carbon here, this carbon. So hopefully we have only 2 atoms attached to it directly. This and this are attached to this. We are not counting the bonds, we are only counting the atoms. Now when we talk about atoms, we are looking at hydrogen as an atom. This is hydrogen molecules telling you 2 moles of hydrogen. So when an element is standing single, automatically it becomes an atom. So this is an atom. Carbon atom is attached to this carbon atom. When you see CH, you should know that this is like this. So you shouldn't be confused. So now this is attached to 2 carbon. This is what we're going to do. We're going to apply the formula sp2 minus 1. Okay, it's going to give us sp hybridization. So automatically this becomes an sp2 hybridization. It becomes an sp, and if you follow our super trick, this is a triple bond already beside it. So this becomes sp3. So following that super trick, we're going to have this as sp3, this as sp3, this as sp3. Now we move down to the next structure. How do we assign hybridization to this? This is a single bond on sp3. This is a single bond attached to this carbon. We're going to have an sp3. Now when you see a chain like this is what happens. The chain, let me make a simple explanation of a chain. And in each of these points you are seeing is standing is a carbon. It's a carbon in each of these points. So we have 6 carbon. So this chain is like this. Let me redraw the chain to open it so that you can have understanding of what is done there. Now these are the 6 carbon. Now in each of this chain, carbon is placed under group 4. Carbon must be bonded to things. Now this carbon is already bonded to this and this. So there's a leftover hydrogen for this carbon to be bonded here. So we have this here. So each of this carbon has this. Now remember, this has a double bond. So this carbon has this also. This carbon has 2 hydrogen also. So because it must be bonded to 4. Now this one has been bonded to 1, 2, 3. So it's just like a 1 hydrogen. This one has been bonded to this, and it has a 1, 2, 3 bond. So it becomes what? A hydrogen. So now you should take note of something. This one was not bonded to hydrogen. Remember the structure looks like this. So it was bonded to another carbon here, CH2, CH3. Now, this one was bonded to 1, 2, 3, 4, making it complete. Now, how do we assign hybridization to it? Now, if you look at this 1, 2, this carbon here, this first carbon is bonded to 1, 2, 2 other carbons, 3, 4. So this automatically sp3, single bond, sp3. This is single bond. It's going to be sp3. This one is a single bond, sp3. Now we move down to this carbon that has a double bond. It is bonded to 1, 2, 3. So here becomes sp2. We move down to this. It's bonded to this one. It's bonded to this one. We're not counting the bond, we are counting the atoms, and it's bonded to this one. So we have 1, 2, 3. So here it becomes sp2. And like guys, I've already assigned for the other one. These ones are sp3. Okay. So let's look at the next structure. This is water molecule. This water molecule, we are going to assign, we are not assigning hybridization to the hydrogen that is attached to it. So this oxygen is simply telling you we have something like this. A hydrogen here. We also have another hydrogen here. Then we have 2 lone pairs. Now, how do we assign hybridization? Now, we are going to be counting the lone pairs as part of the atom. We also count the atoms attached to it. So we have 1, 2. This lone pair is also counted 3, 4. So using this formula that we said sp n minus 1, it means this is automatically an sp3 hybridization because we have 1, 2, 3, 4. So it's going to give us sp3. Now let's move down to the next structure. Let's look at this now. This one, we have a single bond, so it's going to be an sp3 for this carbon. Now we move down to this. This carbon is attached to how many items? It's attached to 1, 2, 3. So this carbon is an sp2. Following the formula we give, this nitrogen is attached to this nitrogen. It's easily drawn like this. We have hydrogen here, 2 hydrogen, and a lone pair, and it also attached to a carbon here. So all we have is it's attached to 1, 2, 3 atoms plus the lone pair 4. So this bond becomes sp3 also. We come to the oxygen. The oxygen is attached to this. So we can do it. We have this oxygen like this, and it's also attached to a carbon. So how do we assign hybridization to the oxygen? We count 1, 2, 3. So this is 1, 2, 3, and when we say 3, we know it's sp n minus 1. It's going to be sp raised by 3 minus 1, which is going to tell us this one is an sp2 hybridized atom. Now we come down to this. How do we answer such a question? Look at this. You simply do what we did: 1, 2, 3. So the one becomes sp2. Look at this carbon. Carbon is attached to 1, 1, 2, 3. These are hydrogens attached to this carbon. So it's going to be 1, 2, 3. So it's going to be an sp2. Move down to here. Ammonia is having 3 hydrogen like this and a lone pair. We count both with a lone pair: 1, 2, 3, 4. It's going to give us an sp3 hybridization. I hope this video is helpful, and if it is, please subscribe, and I'll be dropping more of this content as relating to advanced level chemistry, organic parts. Thank you.